Project 1.2, the 2-bit adder. In order to understand how the 2-bit adder functions, it is vital to understand binary addition, Boolean algebra, integrated circuits, the half-adder circuit, and the full-adder circuit. Binary is based on base 2 arithmetic. In binary addition, when the result of a column or bit exceeds 1, a carry is produced which is added to the next bit. This is similar to decimal addition, when a column being added exceeds 9 and carries over to the next column. Boolean algebra deals with binary values and revolves around logic gates, similar to how the decimal system is built off of addition, subtraction, multiplication, and division operators. The table provides operation, Boolean symbol, and a description of the output for each Boolean logic gate/function. Integrated circuits, or ICs, are small electronic components that contain a network of transistors, capacitors, diodes, and resistors. The ICs used in this project include the quad 2-input 4070 XOR, 4081 and the 4071 OR chip. This pinout diagram shows the lead corresponding to power, ground, and each input and output gate for said ICs. The half-adder adds two single-digit binary numbers and can perform addition up to 1 0 or 2 in decimal. This LED represents the half-adder sum bit. The XOR chip causes it to turn on when only one of the A or B buttons is pressed. This LED represents the half-adder's carry bit. The AND chip causes it to only turn on when both the A and B buttons are pressed. The full adder adds three single-digit binary numbers and can perform addition up to 1 1 or 3 in decimal. It has the inputs A, B, and a carry-in from any previous addition. It is built by combining two half-adders and an OR IC chip. This LED represents the full adder's sum bit. The sum bit is calculated by XORing A and B, and then XORing that result with the carry-in. Therefore, the LED turns on when all three or one of the A, B, or carry-in buttons are pressed. This LED represents the full adder's carry bit. The carry bit is 1 if buttons A and B are both pressed, or if the carry-in button is pressed and the intermediate sum, which is A XOR B, is 1. Therefore, the LED turns on when any two of the A, B, and the carry-in buttons are pressed, or when all three buttons are pressed. The 2-bit adder adds 2-bit binary numbers and can perform addition up to 110 or 6 in decimal. It has the inputs A0, A1, B0, and B1 and produces a 2-bit sum and 1-bit carry. It is built by combining a half-adder and a full adder. The carry-in bit of the full adder comes from the carry-out bit of the half-adder. This completes the addition problem. This LED represents the first sum bit S0. The XOR chip causes this LED to turn on only when one of A0 or B0 is pressed. This LED represents the sum second bit. It only turns on when both A0 and B0 are pressed, only A1 is pressed, only B1 is pressed, only one of A1 and B1 and one of A0 and B0 are pressed, or when all four buttons are pressed. This LED represents the carry, C2. This LED only turns on when any three buttons are pressed, or all four buttons are pressed. After finishing the 2-bit adder breadboard prototype, a 2-bit adder device is made with the parts listed on screen. The device functions the same as the breadboard, but is more compact and practical. 3 IC sockets, 2 dip rockers, and 1 terminal block are soldered onto the PCB. 2 wires connect the power jack to the terminal block, providing the device with power. The PCB is then fit into the case and screwed tight. Finally, a 4070 XOR chip, 4081 AND chip, and 4070 OR chip are put into the IC sockets on the top of the PCB.